Today is how modulus works in 5 minutes. Modulus is this little character. It's the percent character here, and it basically means not more than. So what it really means is it's the remainder operator. So if you're thinking of things like a clock, and your clock has, in this case, 25 numbers on it, it'll go all the way around, and it'll come back to 25, and then it'll go to 1 again. But what it means is if you put the number 30 mod 25, then it'll go all the way around for 125, and then it'll have 5 more. So 30 mod 25 is 5. Now, rand function generates a random number between 0 and rand max, which is a huge number. So if you're trying to generate a random distribution of values for your C programs, you can just call rand. Now the quality of rand isn't that good, and we're going to show you that in a moment. But here we're going to take a look and say 25 rand mod 25. So we're going to generate a bunch of numbers. We're going to generate 100,000 numbers that are all less than 25. So here's that function. And here is our little makefile. Makefiles just do basic input output. So it says here's the dependencies. Given one of these, I can make one of those, and here's the step to make that thing. Given a rand.out, I can make a rand.dat file, and that's how I make one of those. So we can now go to our terminal, and we can type make, and that just ran our little Clang compiler. Now we have rand.out, and we can say make rand.dat, and that made our rand.dat file, and rand.dat is a whole bunch of numbers, word count minus lines, rand.dat. So it generated 100,000 numbers, and they're all less than 25. But one thing that's interesting is that we can plot these using R. So R is a statistical language, and you can come here, import dataset, open file. Let's navigate to my file here, rand.dat, and we'll import this data. That looks good. Import. Okay. Now we have this summary function, and we can just say, hey, give me a summary of the statistics of this file. So the maximum value in the file is 24, and the mean is the average is 11.9. So it's a little bit less than what the ideal mean would be, which would be halfway in between. So that's a hint that our random numbers aren't totally distributed completely evenly. It gets a hint that it's skewed a little bit towards the zero, towards the zero side of the mean. And you can see that here, it's on the median there. So that's what the summary statistics are showing you. But let's actually, pictures are worth 1,000 words. So let's just, let's copy paste this code. So this is just draw a histogram of that one vector there. And you can see that's the plot of values. Let me get my face out of the way. That's the plot of values here from 0 to 25 that we generated with our function. And you can see that there's a little bit more data in this first bin. Now we can adjust the distribution, the bins of our histogram with the breaks function, and let's just break it into like kind of 4 chunks. And you can see that, yeah, there's a little bit more values between 0 and 5, and there's a little bit fewer values between 20 and 25. Let's just play with this a little bit. So let's take a rand of 100. Since 0 is there implicitly, let's do 1 larger. And we're going to generate random numbers between 0 and 100 inclusively. So let's come back here and we'll type make. Now make reruns the compiler because it noticed that our source file changed. And then we can say make ran.dat, and we get a new dat file. And we'll go to import here again, art, personal, data, ran.dat. Okay, let's import this data. Let's take a look at the summary statistics again. So this will be rand v1. Okay, so that's interesting. Look how our mean is, it's kind of even more skewed, right? It's off the median even more so. And then we have that 100 is the max value. So if you look back here, not a single value is larger than 101. In fact, the largest value is always less than 101, which is 100. So that's that summary statistics of the distribution. And again, we can plot this distribution again, and we can see that it's a little bit more even. Let's see what the default histogram plot is. But there's still a skewing of values towards the 0. So there are more values that wrap around and come back. And if you're thinking of the clock, there's more in that 0 to 1 kind of range of those clock values that are wrapping around. So the distribution of random numbers, because of the modulus, is not that good. So if you really want quality random numbers, modulus is not the way to do it. You're also seeing hints of the quality of rand itself here. So again, these are not quality random number generators, but this is how rand works and modulus works. Okay, let's look at one of the other ways that modulus works. You can check for something being even or odd. And it's the same concept, right? So if we take 2 mod 2, that would be 0. So let's take a look at this function here. So let's do for int I equals 0, I is less than 10, plus plus I. And let's just do a printf %d I mod 2. And let's print I too, just to kind of see what the value is. So this would be mod 2 equals, and oops, and let's put a new line in here so that we can read it. Okay, come back here, make. Again, that's just make.ran.c has changed because we put code in here, so the make will rerun the compiler step. And I've been writing too much Go code. And I think we need a literal one of those. Okay. Oops. And then ran.out. So 0 mod 2 is 0. 1, which is odd, right? Mod 2 is 1. 2 mod 2 is 0. And so every even number mod 2 is 0. So if you want to check if something is even, if thing mod 2 is equal to 0, then that number is even. That's another way you can use modulus. And again, it's just it's that wraparound value. When you say mod number, your result will always be less than that number. And then if you're using it to generate distributions, there's going to be a skewing, which you can see in the histogram if you plot it. And that is modulus.